Two. This new OBS mixer is beautiful. I like it. Test. Ooh, echo. What else we got? Alright, so first I just wanted to I don't like diving into, you know, sometimes it's best just to steer clear of the stuff. Hey, my screen is, oh, it's okay actually. I wonder if we can change the view of this to zoom in, like the actual preferences of KiCad. But anyway, so I just wanted to cover something quickly which just annoyed me, and I know, for goodness sakes, that it's not healthy to dive into things which make you feel less than stellar about the human race as a whole. And there's a lot of bad stuff out at the moment, but this one just prickled me, and I think it's just something that I thought I'd so there's this person. I came in here, I searched the internet, right? I'm a newbie. I'm not an electronics professional. I'm developing a project for a hobby, for fun, in my free time, because I'm an electronics enthusiast, right? Somebody comes up to me and asks about software development, I would, I've done it. I've sat down with people and talked to them about what I do, and if they were expressing interest in it, you want to generally help people, and this isn't the first time I've seen this, so normally I wouldn't bring it up, but this seems like a systemic thing in this community, and perhaps it's just because of this as well, I'm not sure, but there are some good communities in Reddit, I must say. That's a brave thing to say. So this person asks, and because like for me, I developed this PCB, printed circuit board design, in KiCad, right? Terrible. I was trying to do too much with too little. I was trying to make it so I could make it myself, learn how to etch my own PCBs. This is far too complex for that situation. I'm going to have to get this shipped away and made by like PCB Way or something like that, right? So that's fine. So I've got to do a second design basically. And I don't want to lose my first one. So really it seems logical that you would have some sort of system in KiCad to create a new printed circuit board based on the same schematic, right? So if you're not that familiar with electronics or KiCad, you've got your schematics, which I thought were pretty central, considering, this is sitting up the top here, edit the project schematic, right? So you've got this whole thing where you do all you put all your parts down, your bits, define all the all the stuff, okay? The actual circuit, all right? This is the general circuit design. Layout for visuals, notes, blah, 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 all that sort of thing, for being able to decipher it later, in my opinion anyway. So to me, that's where I started. And then the PCB layout is a physical layout of the traces, components, and blah, blah, blah. So I would have thought, well, perhaps what if you've got different form factors, but the same project, different form factors based on the same circuitry, or you're just trying to learn how to build a PCB and you just want to play around, you just want to try a few different variants and all that sort of stuff, right? Perfectly reasonable question, I would have thought. So I jump on here and I go, Jane Foster asks, 3 years ago somebody had the same question as me. It's what the internet's great for, right? I have a schematic with multiple hierarchical sheets. Same. I'm trying to create a PCB from one of the sheets. Every time I try to create a PCB, it attempts to import the entire schematic, not just the sheet. Is there a way to get it to create separate PCB layouts for each sheet without having to create and import each sheet as a new one? Okay. So, Sticky Butt Flaps chimes in here. First of all, this must be in an FAQ somewhere. The inflection is my own. As a, yeah. KiCad is centered on PCBs, not schematics. Schematics are an important and necessary part in creating a PCB, but the PCB is the final result. Understanding that makes it easier to understand that one project in KiCad means one PCB. If you want multiple PCB designs, then you need to create multiple projects. That's how you need to think about the workflow. And just adding this for op, instead of having multiple schematic sheet PCB pairs within one project, the purpose of hierarchical sheets is to provide abstraction to improve the clarity and readability of your schematics. It's just like programming, right? Which is cool. Say you have multiple regulators on your PCB with each one having their own passive. Fair enough. I've just got a large project, so I was trying to keep it modular in construction, blah, blah, blah. Have a look at KiCad. So this is a nice response, right? Having read the tone of some of the replies there, and this is what made me keep scrolling, because I was like, oh, maybe I'll have a look at KiCad. But this, I just couldn't help myself. It's like watching a train wreck, you know. You got to keep going. So, cheers. That looks cool. I think there are edge cases when having multiple PCBs. See, nobody's particularly explaining why this is the philosophy. Like, yeah, okay, just accept it is fine. But if you're building a tool, right, for this, and personally, like, nobody's said why is having multiple iterations or multiple PCBs in one project. A project to me is the thing that works, right? So in this guy's case, he's trying to build, he's got different schematics and he wants them as separate physical PCBs, but they'll all fit together as kind of a project whole. I get, yeah, so I do, yeah, anyway, no, you must create separate projects for each. Hierarchical sheets are not meant for unrelated schematics. Unrelated though, it's not. So we'll keep scrolling because some of these aren't that bad. All right, maybe I'm just picking out the bad stuff, but still. Now you have invested enough time on the wrong way. If your global schematic, blah, blah, blah. I think okay, this is the worst one. Okay. I think I've overrepresented how bad this is, but all right, even if you get this to work, it's bad design. One project, one PCB. You ever opened up any piece of consumer electronics? Chances are there are multiple pieces. Are you stupid? One KiCad project. If you need multiple PCBs, set up multiple projects. If you need them made in single panels, combine them at the Gerber stage. I'll just go back to my job where I do this professionally. Good thing you got -6 points there. Oh, I need one schematic across multiple boards, not multiple schematics on one board. Cranky, it's the status quo, so it's right. Combined with this really dismissive, toxic attitude and independent authority, do nothing but help anyone. Good, yeah, I agree. I just, yeah, anyway. It was just a little rabbit hole I went down earlier. Not healthy. Some people just aren't helpful way. Like, why would you be so abrasive when there's no need? Somebody's just asking a legitimate question. Sure, maybe the workflow of KiCad is like, oh, you know, actually it's not really designed that way. It's like you should make multiple projects. but there's no healthy discussion around his use case is actually legitimate. Anyway, hey, that's the internet for you, right? So what I'm doing is I'm trying to, and I don't know what I've done here because I want to, is it just like saved over? Basically, I want to, there it is. Okay, there's my old terrible PCB, right? I tried to do it as a single layer. This is a rat's nest of terror, which took me way too long, wasted so many hours, and really, all I got out of it is how not to do it, which sometimes is an incredibly helpful lesson, to be fair. And I also did a B layer. At the end, I relegated myself to going, okay, I need some big ground planes. And then I learned stuff about ground loops and how this isn't a good idea either, and all that sort of stuff. I'm not doing high-speed digital electronics here. I'm doing moderate speed serial electronics, so it's not too bad. And the fact that I've run this on breadboards with components sticking out all over the place is testament to the fact that it doesn't need to be perfect to run. But anyway, we're going to try and do a better job. And the layout I chose, I wasn't happy with. I was just trying to conserve space too early, and I don't really even have a solid footprint for this thing yet, so it wasn't the best way. It wasn't the best way to start. So I think we need to, well, basically hide all, no, that's not what I wanted to do either. Show all copper layers. So I want to just clear all this out, and basically I want to start again. But I think there is a way that I can actually create a new, like, version or a different variants. So there is an answer, and this might have come in a later KiCad version. So anyway, we need to save this. I don't know how to create a new variant though, so that's a bit annoying. I think it's done at the schematic. Yeah, it is done at the schematic. So I don't know where you manage the variants either. That's the other thing. So if I go try to, and then go here, see what is up with that? I'm going to figure out how to do this and what variants are actually for. KiCad variants. KiCad 10. Brand new, off the shelf, like literally a day ago this was released. Design variants, way to track different versions of a single project. There you go, right? Suck on that, grumpy Redditors, you know. So let's go to variants. Schematic editing. A different bill of materials. Okay. Jumper support. PCB time domain tuning. Now let's see, this is the stuff that is crazy. Like making electricity go through a longer path to adjust the timing by 94 picoseconds. Pretty wild. Make that signal take an exact certain amount of time for high-speed electronics. It's nuts. Very cool, but crazy. Crazy levels of electronics. Right, we're going to hide all non-copper layers. I don't... So, I guess there's no variants for PCBs yet. It's only variants for schematics, perhaps. Which is interesting because I would have thought that with a different schematic variant, you're going to need a different PCB. Aren't you? So variants, here we go. Remove design variant. We're going to remove try to. We're going to go back to default. And now I'm going to switch over to PCB, and I'm going to see if here we have the ability to I don't think we do have the ability to do variants here. We don't. So that's fine. Switch to project manager. So I know I can create different files, but they need to match a schematic. So it's like I have to duplicate the schematic. What's this? I don't know what happened. Just clicked on that and it. MIDI Muse KiCad project. So that's the actual project. Ah, I see. Okay, so what? Switch to this project. And it's created a copy. This is so confusing. So you can have nested projects, right? So, but that nested project can't. Oh, I'm so confused. Project files. So the project file is a file of the project. What? Let's open the folder and see what the deal is here. There's all this crap. So we've got autosaves, backups. We got this rubbish here. I'm just going to delete these test files that I set up. We're going to start again. So let's go into the project here. Refresh. See, where is that file? Oh, there. Okay. This is... What does this look like in Notepad? Damn. That's a lot of stuff. Holy crap. Alright. So if I just delete that project, I think we get back on track. Okay. Yep. So let's have a look at some plugins, because I know FreeCAD, I mean, has saved me from a bunch of pain with their plugins. So maybe I want to actually KiCad multi-board project. Boom. I think we need this. I need this for my amateurness. I feel like my color balance is off on my camera. Oh well. Apply pending changes. Downloading. Cool. Okay. So KiCad is now installed, which is good. How do we use it? Do I just open this up? Oh, seems to have crashed. It's good. Whoop. There it goes. And it's reopened. Right, so what's different? I'm just going to open the PCB and see. No KiCad backend found. You probably installed KiCad only via PCM. Please follow the installation guide. What? My goodness. A backend, a Python library. Not possible to install. Okay, fine. Windows. You have to open KiCad command prompt. Once you have it open, pip install KiCad. Alright, well let's see if this actually works. So, KiCad 10 command prompt. And let's see if we've got pip. We do. Okay, pip install KeyKit. You should get something like this. Sweet. Backend, GUI and libs. Comes with... Okay, so from KiCad 6 onwards. Alright, that's cool. So... Whoa! It's doing it, so it's all doing its own thing here. Right, we'll open up the PCB again. Okay, we're in. We're in. So, what do I gotta sort this my screen out? There we go. KeyKit. So I want to know, how do I create a new board? Do I create a new board? Do this. MIDI Muse. I'll open up the, everything else is closed. I'll open up the schematic. So we've got new designs, schematic hierarchy, that's fine. Tools, switch to PCB editor. It's normal. Preferences. I'm just going to have a quick look in here to see if there's anything. So we've got plugins, KiCad API, we don't need that. PCB editor. Plugins. Nothing. Right. I just, like, I mean, I don't think it's unreasonable to want to create a second PCB, a second PCB design. I don't think I'm crazy. Like, that is an unreasonable thing to want to do. I'm just completely... Alright, so let's go back to this Reddit thread, which annoyed me in the first place. Reopen, close tab. I need the Reddit thread that I was on. There it is. Okay. So let's see. I put things in a single schematic and have multiple boards in the PCB design. Right, okay. So you just make them like next to each other? To me, a project isn't just a single PCB, it's the design process of the whole product. I'm with you, bud. Yeah, guess I'm just not used to this whole, I'll do this, you do that, stay in your lane. Okay, I get it. I do get it. It just does seem weird to have a whole new project for, considering how much, the reason why is because how much in KiCad a project actually dictates, like how much it stores. It's like, it's not just the schematic and the PCB and stuff, it's, yeah, a whole bunch of other preferences that you'd want to maybe maintain across all the boards, across everything. So anywho, this isn't gonna work how I wanted it to work. So what I could do is I could so what's all this? Go hide references, panelize PCB. The currently open board is not empty and it will be replaced by the panel. Standalone PCB new instance. What's a PCB new instance? That sounds like something I want to do. PCB new. I'm going to have to look this up. What is PCB new instance? I did read something about somebody said click a pen board and then like you should be able to open. Okay, I'm going to have to look this up. I have to go to our good old friend, the documentation here, KeyKit. KeyKit. I want the documentation, please. Multi-board. Workflow. First, draw a separate schematic sheet for each of your boards and propagate the pins on the interboard connectors. So this isn't multiple boards for the same schematic. That's just not how it works. What was this PCB new? In a standalone instance of PCB new. Okay, this is all like not what I want. I think I'm just going to have to go ahead and make a copy of this. It just seems bizarre to me, but that's fine. Who am I to judge? You can't copy paste it. Why do they even have the copy paste options in here? Oh, I'm interested in this though, in the schematic version. So if I go add new design, we'll just call it like PCB way version. Right. So I've got that selected. And then if I go here, it's the same. And I've only got the default. All right, I really don't want to lose my progress, so I'm going to what am I going to do? I think we'll just copy the schematic and PCB, and we will rename them the same because they refer to each other, and hopefully hopefully it just works. Hopefully, I've seen people talking about this. You can just copy the files and it will bring them into your project. Refresh, but I don't see the other schematic. And it doesn't have the link to the read netlist and update board connectivity. Netlist file. So there is no netlist file in a KiCad project. Maybe it'd be cool if you could like link it to the schematic. So do I have to export like a netlist or something like that out of here? Generate bill of materials. Learning stuff is hard. Netlist. KiCad. Export netlist. And we'll just call it midimuse.net. So that way I can go into, this might be the key. This might be the way. So if I close this, don't save it, and then go netlist file, like that, load and test, update PCB, added variant PCB way. What? Hold up. Right, I got it. Okay, I think I've got it. So I can go here. I can go into the PCB, and I have to update it from the schematic, because that will bring in the variant, and then with the variant I can go into that, and I could just select all of this, delete it, and then if I go back here, no, it doesn't. What the hell? What is going on? What is happening? This is so confusing. What is the... Okay, maybe... Okay, I'll save it. I'll save it first. Now we've got the two variants in here. And I'm just going to add something. I'm just going to go... I'm just going to add a trace, which goes nowhere. Do that. Right, we're going to save. And now we're going to toggle back to default. And it's still there. Is it broken? Is it... Am I... Am I stupid, like that Redditor suggests? Possibly. Maybe I need to read up how to use bloomin' variants. Okay, let's go. KiCad variants documentation. So this is KiCad 10, right? It needs to propagate. Yeah. Create a PCB assembly variant system. I have some questions. The documentation is in progress and it should be out before KiCad's released. So KiCad documentation for 10, version 10, 9. Do we have version 10? We do. Okay, does it have variants? Starting from scratch. You must start the PCB editor. Okay. Starting from a schematic. Export a netlist. That's what I did before manually, so that worked as well. It's no longer necessary to use a netlist file. Update schematic, board setup. Okay, can I variant? Okay, so we got some variables there. This is all This is all just coding. No search results for variant. God damn it, this is too cutting edge. Too cutting edge. Okay, let's go to the schematic editor. I wonder if it has its own search. Nothing. Variants. Same thing, coding stuff, even less in this one. So I guess I'm just like... I guess I'm just misunderstanding the point of variance. Yep. Panels. It's weird how there's no variant menu in here either. All right. Well, that's enough wasting time. See, so this is how I did it before. I went save a copy, right? So if I go save a copy and I call it MIDI Muse PCB Way, we'll just right over the top of that one that I created before, right? We'll go save. Yes, I want to replace it, right? So for starters, it saved it, but it hasn't changed to that new file. So if I get out of here, I'll just, I don't know, I'll save. All right, so now we've got MIDI, now we've got, it's like its own project inside this project, which is weird. If I click on that, I can switch between them. So then if I go PCB editor, it'll probably load the PCB Way version, which it does. Okay. So, I mean, that kind of I think that's the workflow it's going to have to be. All right, but for now, I need to basically delete everything. So I need to delete all traces, tracks, footprints. Is there a way to delete all tracks? There's a selection filter, that's right. So you can go all items and I just want to select tracks. So I can get those and I can delete them. And then I can go rule areas, I can go zones, points, graphics, is that it? Yep. Alright, now I'm just left with the rat's nest. And turn all selection on again. And I guess we can start trying to lay this out. So the DIN connectors should be lined up. They should kind of interlock. Which they already kind of were. So, whoa, what's going on there? Is that selection? What is that? Oh, lasso selection. Yeah, I just want box selection, please. Okay, so yeah, they should be all lined up. Now, the mistake I made last time was I tried to bunch everything in way too much. So I think, like, it seems to me that this IC here is quite central, and looking at where it's attached to, like if I turn off certain nets, like if I turn off the power and ground nets and we just look at the data for now. Alright, it's kind of central to the header, and the header is connected to those resistors and those ICs. So I feel like going from the header breaking out to the IC, and then we've got these ICs as well. Bloody hell. No, they don't go to there, do they? God, this is so confusing. See, what? I know there's an art to this. I have Googled this before, and it's like, is there any good tips for how to design PCBs? And people are like, yeah, practice, buddy. So I'm confused at what net that is. Didn't select. Okay, so we've got 4 resistors there. That's quite clean. 1, 2, 3, 4. 1. See if we can do any better than last time. 2. Stop dragging labels, for goodness sakes. I should just, okay, what I should do, turn that off and just go footprints. Oh my god. Okay. 3. It's crazy, man. Crazy. 3. Now, I could use AI, because there is something called, what's it called again? Flux.io. But I don't believe that is like, I think that's like a generative thing from the get-go. Like you have to, okay, and then it's connecting to those 4 ICs as well. So 1 over that side. There's like 3 over that side. This is wild. Look how many bits and pieces are coming off there. So this is where I should get into 2-layer stuff, like from the get-go, instead of I should just embrace the 2 layers. So is that all the connections that this needs? It is, except for power and ground. That's all the connections that need. Now these resistors are connected to the relays, and so are those. So it's almost like that belongs up there, and that belongs like that, and then that could work there. We can rotate that. Just want a rough layout for these things at the moment. For each unit, right? So this is a, what's that? A flyback diode. So that protects it against surges when the relay is turned off the magnetic field in the relay has to go somewhere, and we don't want it to go backwards. So this allows the current to flow in the direction we want it to flow. And then we've got, what's this, capacitor? Is that even, that's not even connected to anything. That's random. That's, okay. That's out on its own there. That's just 3 volts. So that must be a power supply capacitor. Some sort of filter or something. What's going on here? This is bizarre. What's that? Net D1. Little confused. And that must be 3 volts. Okay. So that goes to power. And there, that goes there. So we've got a grouping of things here which are all connected to that net Q1B. You know what's funny? I'm probably going to end up with like just about exactly the same design as I had last time. We'll see. So that resistor is, so that's a DIN select resistor. So we've got these, so multiple DIN select. So that's the mode select on the output here. It changes it between output and input. So we've got multiple of these, and they should all be attached to the logic chip here, to the IC. So I can probably arrange those. So we've got DIN select 1, 2, and then we've got 3, and there should be a 4 somewhere up there. So we've got 2 on each side. We could do a resistor bank kind of deal. These are all different values, but that's okay. So I could turn that around. Yeah. I'm going to play with this for now and see how we go. Try and keep this rat's nest from the IC as tidy as possible. And then we've got this, which is another DIN select. See, do I do one on each side, or do I keep it the same side? We've got 2 on that side, I can do 2 on this side. Keep it consistent. This is just rough for now. Rough layout. This should be the last. Is that the last DIN select one? It is. DIN select 4. Okay. So yeah, we've got this huge resistor bank going on. And each of these resistors go right. I gotcha. There's got to be a game. I think there is, like it's Electronic Simulator, like literally called Electronic Simulator, where you can do this stuff. I want some semblance of order components. This is just like a trial and error thing to figure out the best way to actually like arrange components on a board. Write my own rules, you know. Okay, so they're around the wrong way. That one needs to go there. Want to cross, like Ghostbusters say, you know, don't cross the streams. That one is on the end, so that will go last. That one's supposed to be way over that side. Right on the end. Like that. And right on the end. Not sure about that order. Feel like, okay, I am doing 2 layers, so I should just lean into that, but this feels like kind of makes more sense because you can come out there. I mean, that all looks pretty good. There's the only crossing line I have here is that one. And it doesn't, yeah, okay, that's... So what do these connect to? What do these ICs actually connect to? They connect to the relays. So I might just give myself a bit more space here for now. Those are pretty self-contained. That connects to the 3.3 3v3 net, which is just power. And this connects to the relay as well, and ground, the ground plane. So I can almost rotate that like that. This can almost go around the other way. Like that. I shouldn't be crowding myself so much as well. That's the mistake I made last time. Okay, that's kind of its own standalone thing then. In a way. This capacitor can get the heck out because I don't know what I'm doing with that right now. So that's fine. That just sits at the end of the unit, and that one can probably go around that way like that. Okay. I mean, that's it. I mean, that's the components for each one. So, I mean, if there's a quick win, like if maybe that one does make more sense to be on that side for this particular input-output branch. Yeah, okay. All right, well, let's lay out some of the others then. I feel maybe we can push them all together at the end once I've sort of got a general gist of what's going on. Maybe I shouldn't butt them up so close to each other either. That might actually help. I could probably make it stronger by in the case, because it's going to be a 3D printed case. So if I actually have some space there, I can embed them in the case a bit more, and they'll be stronger. It might be a smarter way than trying to interlock them. And in fact, I think the ones that I've got don't interlock properly anyway. So God, I really want to do the software. Okay. Move this into position. This one Go under here. R4. Wait, we've got another resistor, which is basically nothing. GPIO 15. Okay. So we have some more resistors here. Rotate that. Oops. That there. Here's the thing, like none of that needs to cross. Like these two, like that doesn't even need to connect directly to that. There's another GPIO resistor. This one's okay. So that's a simple one because that just goes between the socket and the relay. Yeah, it's this damn resistor bank up the top here, which is so confusing. Alright, let's see if we can bring in the rest here and just get some idea of what we're looking at. Put that there, that can go that way. Right, so switching those around, we've got this U8, it goes there. And then we've got our final, oops, got our final input output. Goes like this. It's one of those annoying ones. And this is looking so much tidier than the last one I did. The only thing is I am ignoring quite badly. I am ignoring the power. 5 and 3. 5 volts and 3v3. Which probably isn't great. Okay, let's go like that. There. Rotate. that there. It's like no matter which way around I do these, what I should do, I should redesign which pins these attach to. To make it all flow better. It's probably possible, like, although the only thing I can do is reorder the DIN select, because these pins obviously for this IC are for a specific purpose. So like I could put like, so DIN select 1, DIN select 2, DIN select 3, DIN select 4. That's probably the best I can do. And then, so we've got TX3, TX. Yeah, because these are different channels. So we've got the power and the ground, and then we've got like channel 1, channel 2, channel 3, channel 3, channel 4. So I need to look at doing this in an order that makes sense. So 1, and in that case both resistors for channel 1 would end up going down this end. Yeah. How the heck did I choose that mode again? I don't even know how I'm doing that. Okay. So 1. Yeah, okay. Actually makes quite a lot of sense. Because that can go around. Interesting. I'm almost seeing... Okay, I shouldn't get too excited about this, but I'm almost seeing a way to do this single-sided again. Although, again, I have not considered power, so I should just... Okay, but it makes logical sense that I should be laying out the channels on this chip in the order that they are on the board. So this should be not 4, but that should be 2. Although I do have... Maybe it should be 3... Maybe it should be 1, 2 on the bottom, which it already is, which is quite nice. So that will go there. And then we've got this here, which would go like that. And there is another resistor somewhere for this channel, which is that one, which can go like that. And that's because that's a 3v3. Cool. Okay. Yeah, so we've got this neat little stack for each. Yeah, a nice tidy little stack for each input output, each socket. Go there. Plenty of breathing room for each one. No idea what those things are. It's probably, I hope I don't need it. These crazy bits and pieces. All right. Ah, that's pretty tidy. That's pretty good. Actually, not bad. In fact, I just remembered why I was trying to cram it into a tiny space. Because that was the size of the PCBs. I was trying to etch myself. Okay. So, I mean, this is good. So what I could do is push these resistors, like, across like this. Could move them across and shove this in the middle. I don't know about that. It's probably not a good idea. I mean, maybe it's a good idea. Maybe it's not a terrible idea. This is crazy up here. Like, what? I like the way that none of this is attached to anything below the resistors in the chip, though. That's pretty nice. This does not go anywhere. Yeah. Now adding in the power nest and ground seriously complicates things. I mean, yeah, look, thinking back to my last work, this is much tidier. I feel like shoving that in the middle is just setting myself up for a similar downfall as last time. So I probably shouldn't do it. But then again, I am me. I do tend to push these boundaries like that. Do things that perhaps are going to stitch me up. I'm not sure. I'm pretty sure there's a way to evenly distribute items along the board as well. So we go align, distribute. Ooh, okay, that doesn't work. Distribute horizontally. And then distribute vertically. Yeah. Okay. So this, I don't think this works. If I go align vertically with even gaps. No, it doesn't. Okay. Right, so align horizontally with even gaps. Align to vertical center. Oh, is that how you do that? I see. How the hell do you actually select these things? Oh. Align vertical center. Gotcha. So then vertical center. I'll just do all of the different component types. I should do this horizontally with even gaps. I should do the same for these as well. This is very time consuming, but you know, whatever. Align vertical center. Why does it look off? It's probably just because it's not distributed correctly. And same with these. Align vertical center and then distribute horizontally with even gaps. That one. Crikey. Okay, I'm gonna pull these down a bit. I don't want the silk screens to interfere with each other. Roughly place them out. We'll do the same dealio. We'll go align, vertical center, distribute horizontally. Cool. That's all looking pretty tidy, if I do say so. Does that mean there should be the same gap between all of those, really? I don't know if it looks like there is, though. Not quite. Okay. Right, these need aligning as well. And distributing. Cool. Tidy. I mean, this does look like this looks a hell of a lot better than my last effort, I've got to say. Feel like I'm just still crowding myself with all this. Like all of that should move up. But that is so much tidier having 1 and 2 and 3 and 4 on the correct sides of that chip. My goodness, that's going to make a massive difference. Crazy, I tried to do it a different way last time. This is the hard bit. I mean, all down here is easy enough. Wire up. Right, better check the traffic, I suppose. $20. No traffic. Cheapest. Right then. Nice. I mean, even crazier. It's not actually crazier, but even, I wonder, even having it around that way might be better. And go like 1, 2, 3, 4. I don't know how large this is. Like, is there a way I can measure? Hello. Thank you. Measurement. Oh. There's got to be a ruler or something. Oh, there is. There we go. Okay, let's go. Let's go. So we have got millimeters, 100 millimeters. 100. Which is kind of nice by 100. 100 by 100. I mean, that sounds good, doesn't it? I'm not sure about this. Maybe it is best to have it horizontal. Have we done it again? We've gone 1, 2. One, two. It's almost like these need to be down more, staggered a little bit. And that should be one. I don't know. I'll align all these. Then I want to distribute horizontally. Align. Distribute. It's weird because, like, it does give it the same gap, which is, I don't actually know how it does that or what causes it to just default to the same gap. Handy. It's good. Not going to complain. There's no getting around the fact that there's these long traces to get from the IC to the resistors. There's just no way around that. And the problem is with that, is that's where the 2-layer becomes necessary. Because the second you draw a trace going from here all the way across there, you're blocking any potential of crossing that line. And especially this way, you could go through and under the resistors, but it just doesn't, I don't know, that just doesn't feel right. I've got two-sided PCB blanks, and so just having the whole ground plane on the other side, the whole other side as the ground plane would like be kind of cool. Make life a bit easier. And then I just need to worry about the 3v3, the 3-volt network. But this mess up the top is going to be tricky, like it was last time. So like I can see here, like getting both of these nets out there, then this 3v3 can cross under there. That's the tricky part, is networking all that 3-volt stuff together as well. This is much tidier than last time, but it's still not Great. So 3 volts could be on the other side as well. I think 3 and 5. There's a few 5-volt rails as well. Could do a bit of a sneaky design for those, I reckon. So power on the other side, and all the data on this side, I think could be the go. We'll see how it works out. These capacitors, I'm not exactly sure what they were for. So let's save, go back to the schematic, have a look at this capacitor. What the heck is that? Oh, that's the logic chip. This capacitor here, I believe, I mean, this is just, it's like some random power filter. I don't like it. I don't think it's gonna do anything. I think I need to reconsider my use of capacitors to filter anything out here, and what actually the heck was that for it all. 5 volts, maybe it was for these, maybe it was filtering here. I think it was for filtering these things, so these should have one of their own between 3v3 and ground. I think that was actually, I think that was on the data sheet. That's why I think I put it in there. I think it was a data sheet recommendation, so I believe, yeah, we're going to need to do that. So a capacitor could go, a nice little thin capacitor, little ceramic. I don't know what type of capacitor it's supposed to be. I think it was supposed to be, I need to look at the data sheet again. I think it was supposed to be a pretty high frequency one, so yeah, we'll figure that out. 3, 4, move across. Could just, yeah, just a little ceramic cap, join those up. Little ceramic capacitor in between each of those. Yeah, like that, except nicer. Rethink my layout here. Where's the ground? Yeah, okay, this just makes a lot of sense. Just to have this right next door. Not taking up a lot of space, and then we can route this some way. Okay, it does confuse things, it does add to the layout. Okay, so we're going to, I think, have to create a bunch of these, and we're going to have to put them on the different sheets. And it's going to go here. Like that. That's a stupid way to do it. Okay. Wait a minute. No, that's not right either. That goes there. Oh, that is fine. That's all good. Actually, that does work. So now I should have one of these on each page, but I don't need it on this page. Get rid of those. And I should have 2, 3, 4, 5. Why is it 2? Can I change that? Reference. C1. Dang it. C2. C3. Oh wait. Reference. C3. C4. Okay, save. Back to the PCB. Gonna update. Now we've got these new capacitors. That guy can go. Yeah. And sit somewhere out of the way. C2. C3. And C4. Boom. Ha. That's a little bit of an outlier now. This whole lot, this whole row here, could move across to balance it out a bit. Yeah, I feel like each one deserves its own capacitor for signal filtering. I'm not happy about the positioning. This does make sense though, because we have 3. Something's bugging me about that. I could bring this down. Rotate that around that way and bring it up here. Thank you. Three. Ground. It just keeps a nice little contained thing there, a nice little contained group, and then the actual data lines have space to move. I think that's good. Right, I'm going to save. I'm going to get off now because I've got to go pick up my daughter, so all done.